Howdy tubes, welcome back to the Zach Life. So this episode we're talking specifically about this diesel fire heater, and then we're going to install it. Now, these were originally made by a company called Webasto or something to that effect. I don't know exactly how you pronounce it. This is not one of their heaters. This is a Chinese knockoff. So when I'm kind of griping about the quality of this thing, this is not a direct stab at the original manufacturer. This is more of the Chinese crap. Now, I couldn't find on the internet when I was originally researching these any information about how they actually functioned, what made them work. And I want to explain very quickly how they actually work, because it's quite simple and it's quite ingenious in its simplicity. Alright, so to begin for basics, you've got a large heat sink here, and this is actually where the heat is transferred. But inside this heat sink is a cube, or a sort of an oblong cube, I don't know exactly what the word for it would be. It's a chamber, semi-spherical chamber that's inside here, and that's actually where the fuel is burned and where the flame takes place. Now up here at the front, you've got a pulse width modulated DC motor. This one's 12 volts. I think they probably come in 24. And this fan here that you can see is actually the fan that moves the air across here. It's actually the fan that moves the heated air. We'll go over that in a minute. But this motor has got a shaft that comes into here, and inside this area here is actually a somewhat of a turbine, if you would. And it actually moves the air that's used for combustion. The suction is here. The air is pumped by that small turbine, mixed with fuel, and blown back into this chamber. And I've had this apart. It looks to me, the way it's designed, is the more fuel that's injected, the longer the flame travel is, and then it sort of makes a loop back up and out the exhaust. Now, we got a few sensors here. Let's talk about what these are. This here is a thermocouple of some kind, a temperature sensor of some kind, that's held in with a spring, and it's got to be there for this to work. This right here is actually a glow plug. These, I believe that the original manufacturer had a spark plug. These Chinese knockoffs have actually got a glow plug. Now, fuel is delivered by this fuel pump, and all this is controlled. And there's a circuit board here. It's all controlled by this control logic. Fuel is delivered from a tank with this small little pump up through this tube and into this chamber here where you've got this turbine spinning. There is no injector control system other than the fuel pump. So when the injector calls for no fuel or more fuel, the fuel pump simply runs faster or turns off. There also is a small magnetic pickup that's down here mounted on this control circuit. You're not going to be able to see it. But it's got a set of magnets in this wheel, and there's actually a tachometer that is read off of this fan. So this pulse width modulation can actually have a feedback input for speed of the fan. I thought this was interesting. I guess perhaps it's a fail-safe where the fuel pump won't run unless the fan is moving air. But it looks to me like of all the cheapness that they try to skip out on this, knowing the speed of the fan wouldn't be necessary, but it's calculating by the pulse width modulated voltage. But anyway, let's put this back together. It's interesting to me. You can actually take this entire case off this thing without a single screw. So this part just sits down in here somehow, somewhere. You've got a few little tabs that line up. Pretty simple, nothing complex. You've got a wiring harness grommet that goes through here. At this point, I'd like you to notice this piece goes on top here. This fan is drawing air in here and blowing it out through on the outside of this case, and what this does is the air is passed out the back here and through and by these fins. So anyway, this piece just simply slides over, catches on this little lip, somewhat snaps shut, and then this little grill screws on the front. Now at this point, this piece here actually snaps on the back, and it's got 4 outlets. When I got it, it had been dropped, and this was broken. You know, thanks to China. It was actually all in the, all the parts were in the box, the broken pieces, and it could probably be super glued together. But I'm not going to use this. I'm going to probably build a fiberglass one, or maybe cut this one up. I'm not exactly sure. Build a metal one, because I want one main vent that goes back towards the front of the coach, and then one small one that goes to the bedroom. I don't want to have to run, you know, 3 small vents out the front of this closet deal. It's just not a good way to do it. So it came with this wiring harness, this single harness, and it plugs in. This is a single plug that actually plugs into the heater. You've gotten, let me get this straightened out here. You've got one cable that comes off here. This is your 12-volt DC power supply. Now, a side note is you cannot switch the power supply. You cannot turn it off and on with the power supply. And the reason being, well, first, it won't come on. But secondly, if you were to turn the power off to this while it was running, the heat that is in that aluminum heatsink is a lot. And that heatsink is very hot. And at the very least, without the fan blowing cool air past it, it would probably melt some wires in here, if not the whole case or worse. The second wire here simply goes to the fuel pump, and the third to the controller. I'm going to go over this controller later. After we put it in, I'm going to explain. I've already figured this out quite a few months ago, if I can remember. So it also came with this piece of stainless hose or tubing and a muffler. The exhaust gas from this, from the combustion side of this, is extremely hot. I would guess 400 to 500 degrees. I didn't measure it, and it's kind of noisy. And anyway, this is a nice piece of stainless to get it, you know, to get the heat away from here, and then also a muffler to quieten it down. And this made a significant difference. With it, it was pretty quiet. Without it, it was actually kind of loud. It sounded, I don't know what to compare it to. It just sounded like a nice little hot fireball burning in there. So we're down here underneath this cabinet. The heater's going to go basically right there. My first step is I've got to hole saw a hole through the 3/4 plywood, and then the 3/16 plate that's over the fender wells. This is going to take a minute. We'll catch you when I've got a hole. Alright, 30 minutes later, I got my hole sawed through there. So I want y'all to keep in mind, this is a little bit of a temporary installation, at least some part of it. This plate goes on here and this screws down. I'm going to have another one of these water jetted out of stainless. It'll go on the bottom. And then I'm going to sandwich both of these together with bolts through the floor. I have got, I'm not sure if you can see, there's actually a gap between the plywood and the steel. And after I get the top part put in, before I put the bottom plate on, I'm going to silicone up all through in here and kind of carve out this spray foam, and then put that bottom plate on so I can't get any water to splash up under the fender well, because the tire is literally right there. No water can splash up through the fender well and get up underneath the plywood. So the wire for the fuel pump actually goes through here. Just like so. And then you've got a couple of nuts to screw on here. We'll drop the fuel pump line through the hole in the floor. Just stick this in there. As I said earlier, the mounting of this is somewhat temporary, and I'm just going to stick a couple of sheetrock screws that'll hold it for now. So I'm going to go ahead and plug the harness in. So 6 months ago, what I noticed with this little controller that'll add to its ease of compatibility with my Dometic climate control system is that if you hold the off button down when you hold the on button down, the heater will run. When you release the on button, the heater will go off. It's probably got a simple ladder logic latching circuit in it, logic circuit. And so what that means is when you hit the on button, it bypasses the off button, basically. So in my air conditioner that's right above you, the #1 air conditioner has got a furnace option, and I've already got the wires pulled, and it's simply a relay that comes down from the ceiling back down underneath to this cabinet where this thing is going to be. So all I need to do is basically permanently make the off button pushed, and then have that relay click and release the top button. So let's take this apart. I assume these are just simple buttons, and let's take a look at it. Now, I have not had this apart. It doesn't appear to have any screws in it, and I assume it looks like it's got a couple of clips. I assume that this will just pop apart. Maybe. Somehow this has got to come off. I hope it isn't glued on. There you go. Well, I got a bunch of clips on the thing. Yeah, all right, here we go. So, yeah, we've just got a couple of switches here. Ouch. Unfortunately, it looks like they are double pole. Actually, they are, but these two over here are not even used. So these are actually double pole switches, but I can tell that, just by looking at it, that these poles over here are not used. So basically, this switch just makes contact between here and there. I'll need a small piece of wire to bridge the off button gap. I'm going to take and tin a small piece of wire here. That way the wire can't come apart. And I'm just going to take and cut a small piece out of it that I need. Now, before any of y'all start laughing at me hysterically, I realize this soldering iron is huge. I've got big solder in a soldering iron because I've been in here putting terminal ends on the wires. And I might destroy everything with this, but we're going to do it anyway. Just like that. Nice little solder joint, nothing special. It's got some of the flux here, but there's not any solder, any connection back to these little resistors. Basically here we're going to do the same thing. This is just some kind of white, probably 20 gauge wire that I've got from somewhere. I'm going to tin the end of the wires, over solder them as much as possible. You want as much of a blob of solder on them as you can get. same thing with the actual switch leads. Go down here and put a big blob on them. Dang it. You probably can't see that, but there's a little bitty tiny resistor I just desoldered off this thing. I've got to put it back on. I'm gonna go get some more proper soldering equipment. So I went to try to find a small soldering iron, and I have got a tiny pencil soldering iron and tiny solder made just to do this, and I can't find either of them, and I guarantee they're both in the same place. So I went and put this under a microscope, and it is a 189 chip, which is a resistor, so it does not matter which way it actually goes. I'm going to see if I can get this oriented back on here. You know, this is not something I wanted to do, obviously, and see if I can get it soldered back on here. So I got it on there. It was this one right here. It's a little bit crooked, but it's soldered. Now I'd like to make a point that I think this is the only thing this did was probably lower the voltage to this LED. So even if it's gone or blows up, I think we'll know immediately if this light either doesn't work or pops. So anyway, back to where we were. We're now going to try to put this wire on. So I've got a significant amount of solder on the wire and this contact. In fact, this wire is a little bit too long. It's like that. Okay, now that I've got a high temp glue gun, and I'm going to squirt a little bit of hot glue right around these connections, and this will insulate it and it will stabilize it so that there won't be any strain on the solder joints by the wire trying to move. So let's put this thing back together.
It may not really go back together well with that wire, and that's fine. I believe it is. Good enough anyway. I'm gonna dollop some glue. I don't know if you can tell, but I forcibly put some in there and it's probably got it back on the back side. I probably should have seen if this worked first before I put it together, but oh well. Ta-da! Hope it works.
Okay, so I got a gallon bucket full of red diesel. I got a clear plastic hose. It's way too long. It runs up the fuel pump. The fuel pump's laying on top of the tire, and then the exhaust just sort of just hanging there. This is worst case scenario. I want to see if the pump would suck through that much line and if it would pump air. Okay, so I got this little lid hooked up. This is going to be a closet, if you don't know, so you'll be able to open the closet and get to that and adjust the temperature output. I spared you on all the wiring just because it's so complex and there's so much of it, you don't care. So let's see if it works. I have tried it and it didn't run, so we're not coming in this blind. Okay, let's see. Mode, we want to go to furnace. It takes this thing several minutes to come on and light. I'm not sure why. I'm gonna spare you the video. I'm gonna jack with it, get it all burning and the air out of it, and then I'll catch you back. All right, so I'm gonna give you my honest somewhat scientific assessment of this heater. Now I'm going to start off by saying I really don't like it. I think it's a piece of junk, and that's unfortunate. I'm not someone that buys something and then makes myself love it because I paid for it. In fact, with me it's usually the other way around. I usually hate it. So the first thing I want to say is it's extremely noisy. And I don't mean like extremely noisy, like, you know, sitting beside a generator, but it's really loud. It's running on like about half speed right now, and you know, the little controller down here is set halfway. And you'll notice throughout this video, the fan speeds up and then it slows down, and it speeds up and it slows down. And I think what's happening is that temperature sensor is reading the temperature of the big chunk of aluminum. The fan slows down, it gets hot, the fan speeds up and cools it off, and then it slows back down and goes through this cycle. If you run it wide open, you know, it's loud all the time, and I think that's better than it being loud and soft and loud and soft and loud and soft. The other thing I hate about it is even if you've got it on low, when you turn it off or when it goes off, the fan goes to high speed, I guess to cool that heat sink off, and it gets really loud. And I mean, I think that's totally stupid. So anyway, I need to show you where you can get it. Here's a screenshot that I just screenshotted off eBay. This is probably not the actual place I bought it. I actually bought this thing last January, like a year ago last January, so I've had it for over a year. But it was advertised, it looks just like this one, you know, whatever, I'm sure it's about the same. So it was advertised as an 8,000 watt, 8 kilowatt diesel fired heater. And I don't know why they would try to express the heat output in kilowatts instead of BTUs, because that's the standard. But anyway, 8 kilowatts resistive heat is 27,000 BTUs. So this thing was advertised as basically a 27,000 BTU heater. Now, I'd like to tell you the trouble I had with it today. I can't necessarily blame this on the heater, but this is something to consider. It's basically 0 degrees. I think the high today was about 4 or 5 degrees. So last night we hooked it up. You saw me freeze my butt off out there trying to get the little long tube in the bucket of diesel. And I lit it and it ran great for about an hour. I turned it off. I turned the electric space heaters I've got back on because I didn't want to take the chance of this freezing last night, you know, ensuring the plumbing up. And so this morning I came out here, turned the space heaters off, and turned the heater on. Well, the heater comes on and lights. I'm freezing to death. You know, I just had one spacer heater running. It was like 40 in here. I come back a couple hours later, and the heater was not running, and everything was extremely cold. I had a bucket of water here that had frozen. Hopefully, I didn't screw up any of my plumbing. So anyway, I jacked with it. It would light, then it would go out. It would light, it would go out. And I thought maybe the diesel was a higher viscosity because it was colder, and it was extremely cold. I think it was negative last night. It probably around 0. And so I cut that hard plastic line off till it was short, thinking that was a problem. Well, sure enough, I come in here and light it. It lights up, burns great. I went back in the house. Come back an hour later, it had raised the temperature significantly, but it was off again, same deal. And I ultimately determined that the diesel was gelling in that little bitty plastic hose, and I took a heat lamp and put on the little bucket of fuel and the plastic line, and then basically that fixed it. It's been running since about 10 o'clock this morning. It's 10 o'clock now. It's been running 12 hours. So anyway, it ran all day. I came out here and got a good actual fuel measurement at it was 15 minutes till 5. It's now 10 o'clock, or it was 10 o'clock when I looked out there again. And it used 54 ounces of fluid and 5 1/4 hours, 5 hours and 15 minutes. Now, 54 divided by 5 1/4 was, I gotta look at my cheat sheet here, it was 10 1/4 ounces per hour of fuel. Now, diesel has got 137,000 BTUs of energy per gallon. You divide that by 128 ounces in a gallon. I think there's 128 ounces in a gallon, isn't there? Yeah, I was looking at a graduated bucket. You come up with about 1,070 BTUs per ounce, per fluid ounce of diesel. Now, 1,070 BTUs per ounce times 10¼ ounces comes out to 11,000 BTUs. So this 27,000 BTU heater is only consuming enough fuel to make about 11,000 BTUs of heat. Now, you know it's not 100% efficient. It can't be. So best case scenario, this thing is putting out about 10,000 BTUs of heat, you know, and it's advertised as a 27,000 BTU watt heater. Now, as a reference, a 1,500 watt electric space heater is going to put out about 5,100 watt BTUs. And so basically this thing, you see it's wound way back up again. I hate that, that's so stupid. So basically this thing's putting out about twice what a 1,500 watt electric space heater would put out. Now, from the time of 15:05 till 10 o'clock, I left one space heater running and I left this running. And the temperature when I got back was 52 degrees. It's about 0 outside, so we had a raise in temperature of about 52 degrees. Now, when you walk through this coach in the front here, the back's not bad, but the front is really cold. And if you look right there, see that snow that's dammed up and on the floor, it's blown in through the crack where those two steel panels meet, because there in the middle there's nothing screwing them together. You know, that hole's going to be cut out to get into the truck. And so there's a lot of draft, there's a lot of heat loss up there. And I feel like that the one space heater probably doesn't make up for the heat lost in there. So I think once this is insulated out, if you're running only this diesel heater, it would bring the temperature up 52 degrees without the space heater. I've rambled on, I know. I hope you made sense of that. I'm thinking that the space heater offset my heat loss through the lack of plywood and stuff in here. Now, this wasn't what I hoped for. You know, I wanted this thing just to smoke it out in here and you know, obviously burn more fuel, because you got to burn more fuel to make more heat. But that isn't what I got. You know, this is typical Chinese crap. I griped about the you know, the thing going up and down its speed, and I think I could probably take a PLC and control this thing better than the factory controller is controlling this thing, and that may be something that happens. I'm a little bit scared of doing that, just in case it gets extremely hot or something, you know, whatever. But not that I think my controller would be any less or more prone to failure than the Chinese one, but whatever. But anyway, I wanted to give my honest opinion, because I'd looked at these a year ago. They didn't make a lot of sense to me how they work, because there wasn't a lot of reviews, or there wasn't people like me taking them apart or explaining how they worked. And I just didn't know, you know, and I hoped it would work. You know, you read about it on the internet, and my big problem with reading reviews of things that people do is often someone will buy something and they're like, oh, I bought this heater, it's the greatest thing that ever existed. You know, it's in sliced bread and sliced cheese and bologna. But in reality, it's a piece of junk. You know, they just like it because they bought it and they want to like it. That's not to say that this isn't useful. It's not to say that it isn't something someone could use or would be great for a certain application, because I think it could. I just want a nice, quiet coach that's got plenty of nice, hot heat in it. And this just didn't deliver what I wanted. It's noisy. It's the control system is a absolute joke, and the fuel and the heat output is just right over a third of its advertised heat output. Now, I'd like to add that I think this will be fine for me. It's not what I wanted, but I think it'll work. I'm going to put permanently installed electric wall heaters, and I'll do a video about those specifically at some point in the future. But I have actually taken the control board for the air conditioner that's in the bedroom apart, used the heat strip relay that's inside the board, moved some circuitry around so that if you turn the furnace on in the bedroom, it actually energizes that heat strip relay, and then it's got a piece of Romex that comes back out of the air conditioner, back down this wall, and I'm going to put a permanently installed electric heater that looks just like a grill vent. And I actually bought it a year ago too, and I can't find the stupid thing. It was kind of high. I guess I'm going to have to buy another one. But anyway, I'm going to have one in the bedroom and one up here. So I'll have basically 10,000 BTUs of electric heat and 10,000 BTUs of diesel fired heat, and I can use whichever one according to you know, if I've got free electricity or not, basically. And then if it's extremely cold, you know, if it's something like this, we're down, you know, 0 or sub-zero, you know, it probably will require both heat types to heat the coach. But anyway, I guess that's about it. I wanted to give a good, honest review, and I think I probably did. Hope y'all enjoyed watching. I know it was probably long and boring, and only someone that's interested in these stupid piece of crap Chinese heaters would be interested in watching it. But if you did, I appreciate it. I've actually got, I'm not going to show you, but I've got a really good start on the bedroom back here. I'm going to try to get the bedroom completely finished before I move forward, for reasons I'll explain later. But I've actually got 2 videos worth of stuff already done, and I'm working on the video, so I should have a video out every week for the next few weeks. And I know I've been sort of slacking. I've been having to actually make a living. But anyway, appreciate you watching, and we will catch you next week.